me, David Heil, as we dive into this season's first Newton's Apple, approach terminal velocity, construct amazing faces, and hang around with baby orangutans. All this next on the season premiere.
Welcome to Newton's Apple. Newton's Apple is made possible by a grant from DuPont, makers of better things for better living. And also by this station and other public television stations. And now your host, science correspondent David Heil.
Thank you, thank you. Welcome to Newton's Apple, the show that answers your questions about science, technology, and the world around us. I'm David Heil, your host for the 6th season of Newton's Apple. You may be wondering what happened to that other guy, Ira Flato. Well, after 5 seasons of being pinched, dunked,
that's good.
Bitten,
Easy, isn't it?
set up, and down, Ira decided to pursue other career options.
I'm ready.
Actually, I've been a big fan of the show for years, and even though Ira warned me, it wasn't until I started that I realized what being a host is all about. Ooh, how about this brown stringy stuff in here?
Okay, you can run.
Oh, thanks.
Good.
Besides working with Newton's Apple, I'm Associate Director of the Oregon Museum of Science and Industry, where I develop science exhibits and educational programs for the whole family. I spent a large part of my life inviting people to learn about and enjoy science. And after working on this year's programs, I'm eager to share with you another great season of Newton's Apple. From the aardvark to the toucan, air traffic control to rockets. This will be one explosive season. So let's get right to that first question.
My name is Kevin Gordon, and I watch Newton's Apple on KDIN in Des Moines, Iowa. I've always been so amazed when I see skydivers on TV, and I wonder how fast are they actually falling, and how do their parachutes work?
Good question. I've always thought it looked pretty amazing myself, not to mention a little unnerving. Experienced skydivers can free fall for 60 seconds at speeds up to 200 miles per hour. And while I wasn't quite ready for that, I did agree to give tandem jumping a try, a system where students and instructor are actually strapped together for the duration of the jump. That way the instructor takes care of all the details on the way down, like pulling the ripcord. With that in mind, I arrived at the Pacific Parachute Center in Sheridan, Oregon to meet my jump master for the day, Sandy Mathewson.
I don't know where she is. Sandy said she'd meet me right here at about 10. Maybe she's late.
David!
Sandy! Whoa! I didn't expect that.
Made it, so you want to make a skydive, huh?
Well, that's what you've heard. I want to talk to you about this first.
Oh, great. Let me get my chute together here and we'll go into it.
How did I get into this one?
Hello? Yeah, uh-huh. You want me to jump from a plane? Uh-huh. No, that's a great idea, really. It should work really well, huh? Yeah, okay. We'll see you next week. What I do for science? Jump out of a plane? They've got to be kidding. What am I going to do? I know. I'll find Jan Dabrowski. He's a physicist. Maybe he knows something about skydiving. Jan, I just got a call from Newton's Apple. They want me to jump from an airplane. What do you think?
David, you and I need to talk gravity. Come with me.
Gravity? Instead of taking me to his lab, Jan took me to the roof, where he explained a couple of things about falling bodies. When an object falls, including a skydiver, 2 forces act on it. One is gravity, causing him to go faster and faster. The other is air resistance, which pushes up against the skydiver and slows him down. When the force of air resistance balances the force of gravity, you stop accelerating and fall at a steady rate. It's called the terminal velocity, and for skydivers, it's about 120 miles per hour. The thing that prevents you from continuing at that speed, which is what I wanted to know, is to change your aerodynamic shape.
Here, I'll show you how this works. Hold this piece of paper for a second. Now, this is going to be you without your parachute open.
That's just a crumpled mass, huh?
This is before you jump.
Oh.
Now, without a parachute, you've got a certain amount of air resistance, but it's small. And
Okay.
as you go out the aircraft,
Whoa, look at that. Just drops like a rock.
right. Now, what's going to happen when you open your parachute is the parachute will have a much larger area. That means there'll be more air to push against, much more air resistance, and instead of falling fast, you'll fall slow. We'll do that with this piece of paper. Same paper, but this time a different shape.
Same mass, but because of the shape, it just slowly drifts down.
Right.
It's gonna have a nice soft landing. I like that.
You will too, provided your chute opens.
Oh, great.
So, are you ready to go?
Ready just like that? Like,
Sure, we can go get a jumpsuit for you, and then I'll start showing you the gear, and we can make a skydive.
you're serious?
Sure, just come with me.
Okay, here we go.
As you can probably guess, I had a few questions for Sandy regarding the parachute.
Okay, so where's the ripcord? That's what I always think about when I
Okay.
think about parachutes.
The ripcord is this handle here.
Okay.
It's a long cord that comes through the housing and holds the
Right here.
container
So that
closed
pin
here.
just pops out when we pull on it. huh?
Right. And inside is a spring-loaded pilot chute, which will bounce off your back and catch air. Do you want to try it?
Yeah, let's just pull it right
Go
here on the
ahead and-
table here, huh?
right,
So
just-
just pull this straight
Just
out.
pull it straight out.
Rah!
Pull it hard.
Whoa!
The ripcord is pulled when the skydiver's altimeter registers the desired altitude for deployment, generally at about 2,500 feet. The pilot chute springs up off the diver's back, catches air, and acts like a mid-air anchor. As the diver continues falling away from this anchor, the suspension lines are pulled right out of the pack.
All of the lines
Boy, this is really fancy in
are
here, isn't
stowed
it?
in rubber bands like this so that it's nice and neat. You want the lines.
So my parachute is put together with rubber bands. In a way.
Yeah, lines and rubber bands
Okay.
and strings. And so when you deploy, it all comes out
Now,
in
do
a nice
these-
sequence and stays nice and neat.
After the suspension lines have been pulled taut, the main chute, which has been held out of the way in its own separate bag, pulls open and inflates. At 120 miles per hour, the opening procedure takes between 200 and 300 feet, or approximately 3 seconds.
At the nose of the canopy, you've got what are called cells. See this big
This is just,
area? This is called a cell.
this just fills up
And
with
it
air.
fills up with air, and it's closed off down at the tail of the canopy here. So you've got a big inflated tube, and there's either 7 or 9 of those, depending upon the type of canopy that you're jumping.
The 2 layers of nylon are open at the front and closed at the back. The air flows in at the front and inflates the cells, creating an envelope of air shaped much like the wing of an airplane. Air passes over this wing and creates lift, giving these chutes a forward speed of 25 miles per hour and a great deal of maneuverability. Unlike the older round parachutes, which basically dropped you straight down, these ram air chutes are actually flown, much like a slow-flying airplane or hang glider. After finding out how the main chute worked, there was one more nagging question I just had to ask.
Okay, I'm
Right.
feeling better. Now, if this doesn't open, and let's just play this out for a moment. If the chute comes out and it doesn't open, or the ripcord gets hung up somewhere, the rubber bands don't work right, what happens?
Right, we do have a second chance. We have
All
a
right,
reserve
I'm glad to hear
parachute
that.
down here.
Sandy planned to start our skydive at 8,000 feet
FAA
and deploy our main chute at about
regulations and
4,500 feet.
requirements that every
If that didn't
skydiver
work,
go
we'd
out
pull the
with two
reserve
parachutes.
parachute.
The main, which was
And
in
if for
here.
some reason we couldn't pull the
Sometimes
reserve,
problems
there's
happen.
yet another
And then
backup
keep
system.
falling. Because of that, we have what's called an automatic activation device.
This is the last straw
Right, this
here.
is a
Good.
basic
Okay.
emergency device. It works on barometric pressure. If you're still falling at a certain rate of speed, like if you're still in free fall, at the altitude that you set it to, like 1,000 feet, then this will
automatically opens.
pull this cord, a pin fires, and it'll automatically open the reserve for you.
Okay, feeling better.
Later, it was on to lessons in steering, putting on my gear, and learning how to exit the plane with a minimal amount of difficulty.
At this
Okay,
point,
I know how a turtle feels.
I'll say, put your hands on your harness.
Okay,
You'll be
so
able
I
to hear me say
grab,
that.
You want me to do
Both
this?
hands.
Right now in practice? Okay,
Right.
there we are.
And I'll say, drop your feet.
And I just drop them?
Go ahead and drop them. Okay. Then I'll say, ready, set,
Whoa!
go, and we'll go.
All too soon, the time had arrived. The plane was taking off with me in it. I can't believe I'm going through with this. I'm about to jump straight down at 120 miles per hour from a plane, 8,000 feet in the air. Just think positive, David. Just think air resistance. It all happened so fast. 1 second you're hanging onto the plane, and suddenly it's gone, and you're flying. Sandy deployed the drogue chute first, which is a small separate chute that tandem jumpers need to help them stabilize and slow their descent. Freefall is pretty hard to describe, and falling through a cloud was unlike anything I've ever experienced. You become completely disoriented, and then suddenly the ground appears. When the main chute opened, our speed slowed down from 120 miles per hour to 5 miles per hour in roughly 3 seconds. During those 3 seconds, you experience something called opening shock, and believe me, there's a reason for that name. But after that, I began to relax. I started to enjoy the view and practice my steering. The maneuverability of the parachute is amazing. By pulling on the right toggle, we turned right, and with the left toggle, we turned left. Pulling down on both of them was like putting on the brakes right in midair. It pulled down the tail of the canopy and changed the shape of the airfoil like an airplane wing during landing. This slowed down our forward speed, gave us a little bit of lift, and a nice, soft walk-away landing.
I'm here, okay? There we go. Yeah! Oh, yeah! It's just, I don't know what you said.
I think he liked it. He'll be right back.
I loved it.
More party trivia. Fascinating fact number 48. Cows. Cows can change the weather. Belches from our steadily increasing cow population contribute methane to the atmosphere, adding to the greenhouse effect that is warming our planet. The 1.3 billion cows on Earth belch 650 million pounds of methane every day, enough to raise the temperature of our atmosphere 5 degrees in 60 years.
When does a visual pattern become a face? How do we communicate through facial expression? The Reuben H. Fleet Space and Science Center in San Diego has developed an exhibit to answer some of these questions. That's where we sent field reporter Peggy Knapp.
During our lives, we see and remember thousands of faces. In fact, face recognition is absolutely key to human survival. But we're so used to seeing our own face in the mirror that we've stopped asking questions about it. We take our own face for granted. You've seen my face before, but have you really noticed it? If you were asked to describe my face, what features would you pick out? Do I have any distinguishing characteristics? Scientists are seeking to understand how we remember and communicate with our faces.
The Reuben H. Fleet Science Center in San Diego has developed a number of exhibits that demonstrate just how important the face is for understanding communication. Elsa Fayer, Science Center Director, began by showing me how we can easily recognize faces in abstract patterns.
What you're looking at over there is, in fact, you. Just that.
I'm looking very rectangular.
So let's see what adding some information in the form of more and more pixels can do, and how much of that you need to do in order to make that blot become a face.
Well, I could
begin to
start to see a face
Right.
there.
Why don't you try adding shades of gray by using these buttons here?
Oh, that helps a lot.
Yeah.
Now, see, I can already recognize that as myself.
I can too. Why don't we see what you look like in full resolution?
Looks just like me in black and white. You don't need very much information to not only see a face, but to recognize your own face.
Your own face. Correct.
We can easily see faces in abstract patterns because we get so much information from the face. It's the face that tells us whether someone is a friend or a foe. Babies learn the distinctive features of their mother's face in the first few hours of life. We can recognize and discriminate between thousands of different faces over the course of a lifetime. There's no other category of nonverbal communication remotely like it. Although we're very good at recognizing a face we've seen before, we have a hard time reconstructing a face from memory. This demonstration tested my ability to remember a face. This is a computerized version of eyewitness tests given by the police. I was trying to reconstruct Paul Avery's face. Paul is in charge of exhibit design, and I saw quite a lot of him while I was at the Science Center. Still, it was very hard to find exactly the right hair or the right mouth. I had hundreds of different facial features to choose from, but this was the best I could do in attempting to reconstruct Paul's face from memory. Scientists theorize that the way we remember faces is by comparing them to an ideal face in our mind, which is a composite of all the faces we've seen in our lifetime. The more different a face is from our ideal or prototype, the easier it is to remember.
So therefore, if you see a face that has, for example, a very prominent nose or very close-set eyes, by comparison with your prototype, then you will remember that face more easily.
But if we lived in a mostly Asian society, our individual prototype would probably not include many European or African faces. Our face is the most convincing proof of our individual identity. There are approximately 80 muscles in the face capable of producing over 10,000 different expressions. This exhibit shows us how emotions are communicated through the face.
Would you like to try an expression that conveys an emotion?
Yeah.
Okay, pull up your eyebrows, open your eyes, and open your mouth, relaxed. All right, what do you see?
Surprise!
Surprise, surprise, right. The interesting thing about that is that if somebody came from a totally different culture into this room, Africa, Asia, and saw that expression on your face, they would know that you, Peggy, are surprised. Because there are some expressions that some emotions that are expressed in exactly the same way throughout cultures, across cultures.
Universally?
Universally.
Paul Ekman and his colleagues have identified 6 universal expressions. Can you pick them out of this group of 12? The universal expressions are happiness, sadness, fear, anger, surprise, and disgust. This exhibit tests your ability to identify those expressions when you're given very little information. It's as if you're looking at someone who's very far away from you. Some expressions are easier to identify from a distance than others.
Well, this says select surprise.
Excellent. Now, surprise is one of the easy ones. You have little information there in the form of pixels.
Okay.
And the question is, which one is it? And you will be looking for
Eyebrows.
Raised eyebrows, open eyes, and an open mouth.
Okay, we'll try this one.
Good.
It
You
was
see, it is easy. With very little information, you found it.
Okay.
Now let's try a harder one.
Okay.
Anger. Very good. Let's look for anger. What would you be looking for in anger?
Tight mouth, eyebrows close together.
Eyebrows close together.
Wrong. Try again.
Okay, now, when you try again, you're given more information. There's more pixels over there, and also everything has been randomized.
Oh,
so that
process of elimination.
Process of elimination won't help you here.
Got it.
Very good. That was 2 tries. Actually, that was pretty good. It takes some people more than that.
As far back as Darwin, scientists have speculated whether expressions are innate or learned. We do know that babies have been seen to smile and frown in the womb. Besides communicating feelings, our face also communicates our identity. I thought I knew my own face pretty well because I see myself in the mirror every day. However, when I looked at just half of my face at a time, it looked like the face of a stranger.
Well, we can dramatize that, Peggy. There are other 2 buttons in this machine that give you composites of your face. So it'll show you yourself as 2 left halves.
That's my 2 left halves?
And those are your 2 right halves.
Oh, that's so strange. My right halves look kind of mean. My left halves are chubbier, but I think I'd rather be chubby than mean. My mouth is crooked. Now, why is that?
The expressions that you put on one side of the face are mostly, not totally, but mostly controlled by the opposite side of the brain, especially as concerns the lower part of your face, for example, your smile.
The left side of the face is generally happier looking than the right. The reason for this is far from clear. It may be that the right portion of the brain specializes in producing those expressions. It's also possible to make some pretty fine-looking monster faces on the asymmetry computer, just by doubling half of your face.
Wow! You can make some great faces with this. Why do people like to do this?
Well, that's, the whimsy aspect of this whole thing is sort of interesting. I think that people like to explore essentially, the limits of their humanity. I mean, over there you're marginally human. You're really pretty much like Miss Piggy, right?
Marginally human is at best.
Marginally human. And so in a way, that's, I suppose, what you're doing, if we want to try and explain it.
Let's make my nose really fat.
I think that you laugh out of relief, frankly.
Do you think so?
I think it's very relieving to you to go back and see that that's not what you look like.
I'm tremendously relieved that I don't look like this. More than I can tell you. We can easily explore the two hemispheres of our face with just two small mirrors placed at right angles to one another. Paul Avery showed me how these two mirrors can create the same effects as the asymmetry computer.
A simple device such as the mirrors, in this case, these simulate what asymmetry does.
Really, that's great.
By splitting your face down the middle, you can do exactly what it does.
Yeah.
I get two left halves.
And I get two rights.
Right.
And I still don't like my right side. Our face is an ever-changing pattern of expression. Whether we're exploring the limits of our humanity or studying the face to learn how it signals emotion, our face can provide the keys to understanding human communication.
If you have a science question you'd like answered by Newton's Apple, write us. Send your question to Newton's Apple, Box 1983, St. Paul, Minnesota, 55111. Remember, our show depends on your questions.
No, this is not a fashion show. It's a prize exhibit at the Inventors National Convention. Leggings of lace to outwit hungry mosquitoes, just too ducky. But wait a minute, look what's over here. No, the gentleman isn't getting a permanent. He's having his mind read by the psychograph. This very simple apparatus analyzes your character by the bumps on your head. It tells you all the things you want to know about yourself and some you probably don't.
I hope this thing doesn't tell what I'm thinking here.
Lazy Man's delight is the handy-wandy newspaper holder. And if you haven't the strength to mix your own cocktails, the oscillizer is the last word. What a wonderful world this is. Wonders never cease. Here's a handy hot water bottle shaped to fit the face. Guaranteed to keep away wrinkles and maybe friend husband, too.
Our next guests are just cutting their teeth, they play with rattles, and they love to be held. And why not? They're babies. Baby orangutans, that is. And here to tell us more about them is naturalist Nancy Gibson. Welcome, Nancy.
Thank you.
Have you got names for these two little cuties?
We certainly do. You're holding little Teak, and he is 4 months old, and I have Amber in my arms, and she's 5 months old. And they were both born at the Como Zoo in St. Paul.
Nancy, I cannot help but tell you how much this feels like holding just a real baby.
Yeah,
Human
complete
baby.
with diapers, I might add.
With diapers.
Very necessary precaution.
Thank you for the diapers.
Yes.
Good thinking.
Well, they are closely related to humans. In fact, they are the third closest relative to humans. They're in the family of great apes, which includes the chimpanzees and the gorillas.
And when you say third closest relative, how close do you really mean?
They share 98% of the same genetic material.
Really? Only
with
2% of the genetic material is different?
Right.
Boy,
But you
I can see some of that. That's
yeah,
right.
Right. Let's hold up Amber here. She'll cooperate here.
She just wants to get over here and talk
Right.
to Teak.
Yeah, I think she does.
Look at those feet. Now, their feet are almost identical to the hands.
Right. And they will certainly use that for climbing in the
And
trees.
grabbing toys, like grabbing
Good.
anything,
Right
huh?
on cue.
Look at
That's
that.
great, Amber. And look how long her arms are.
And strong, too.
Very strong.
Yeah.
The arms are about 1.5 times longer than the leg.
Now, when you say hanging in trees, how much time do they spend in trees, really? Just to
Practically
travel?
their entire life.
Really? So they
Except-
nest in trees and everything?
Yes, and they are spending most of their time looking for food.
So is the food in the trees as well? They eat things in trees?
Right. They live, they're from Indonesia.
Mm-hmm.
2 islands, the Borneo and Sumatra, and they're 2 subspecies. One from Borneo, one from Sumatra.
What do they eat, actually?
Fruit. They have a consuming passion for fruit, and I brought along some fruit here. If I can get Amber to calm
try
down.
to feed one of them here?
Right. I will practice some of my maternal instincts here and see if I can get Amber to eat some orange. They eat a variety of fruits, about 300 different types, And the most notables that we would recognize would be mangoes and figs.
Let's try teak here. He seems to
Amber
look like...
didn't work, but
Oh,
later
he just
on.
grabs the spoon. All right.
Right. Oops, spit out the orange, but eat the bananas.
All right. That's great.
They'll also eat some bark and leaves and occasional insects.
Now, they're so cute right now, Nancy.
They are
What do they
cute.
look like when they're adults? Are they just as cute?
Well, it's sort of a matter of opinion. I do have some footage, though, and I'll let you judge for yourself.
Oh, look at that face.
This is the large Bornean male. Notice those big cheek
Wide,
pads.
yeah, the wide face.
And he also has a big throat sac for his territorial loud calls.
Oh, he's hanging in the trees like that.
Now, this
Feet,
is incredible.
hands,
This animal weighs between 150 and 200 pounds.
and still swings in the trees
And
like that.
swings in the trees. And I'm not saying 10 feet above the ground. I'm talking 30 to 70 feet above the ground.
Oh, look at that, swinging with the young attached.
You can see how important clinging to the mother is.
Boy, I can see that.
But it's also something that they have to learn from their mothers.
So it's not innate. They're not born with that ability,
Right.
really.
And so that's why we brought along this climbing apparatus, and we'll see if Amber will demonstrate if she'll let go of
Amber
me
had
here.
some climbing lessons
Yes,
here.
she has had some climbing lessons.
Look at that cling.
Another interesting thing about orangutans is the fact that they are basically solitary, except for the mother and her dependent offspring that will stay with her till they're about 3 years old, till they're completely weaned.
Are orangutans endangered at all?
There are two glimmers of hope. First of all, they've had some success in releasing some of these captive animals back into the wild. That's why it's very important that the zoos are breeding these animals. And secondly, the Indonesians have a great respect for these animals, and they've set aside some reserves for them, and they're protecting those reserves.
That is good news. I'm
Right.
glad to hear that. Nancy, thanks so much for bringing both of them in today. That's about all the time we have right now. We'll see you next time on Newton's Apple.
Newton's Apple is made possible by a grant from DuPont, supporting an interest in science today so that future generations may continue to enjoy better things for better living. And also by this station and other public television stations.